The Viking mission, a game changer, in the vast, desolate expanse of space, where humanity could only gaze with endless curiosity, two spacecraft embarked on a journey that would challenge everything we thought we knew. Their names: Viking 1 and Viking 2. Their mission: to land on Mars and answer one of the most profound questions in history. Are we alone? Unlike any Mars probes before or since, the Viking landers carried a groundbreaking set of life detection experiments. When they touched down on the Martian surface in 1976, anticipation ran high. Viking 1 landed in Chryse Planitia, a vast, dust-covered plain, while Viking 2 descended in Utopia Planitia, a colder, rockier expanse. These landers were more than just robotic observers. They were equipped with tools to analyze the very chemistry of Mars, searching for biological activity hidden in the alien soil. Among their instruments was the labeled Release experiment, an ingenious test designed by Dr. Gilbert Levin and Dr. Patricia Strout. The experiment was simple yet profound. It introduced a nutrient solution laced with radioactive carbon into a sample of Martian soil. If life, even the smallest microbes, was present, it would consume the nutrients and release radioactive gas as a byproduct. And then, something extraordinary happened. The experiment returned positive results, twice, at two different landing sites. The Martian soil reacted. The nutrients were consumed. A clear sign of biological metabolism, but what followed next was even more astonishing. NASA dismissed the findings. Another experiment, the Gas Chromatograph Mass Spectrometer, GCMS, failed to detect organic molecules in the soil. And despite the fact that the GCMS was never designed to detect microbial life, its negative result overshadowed the Viking findings. NASA declared the Viking results inconclusive. The historic moment, possibly the first ever discovery of extraterrestrial life, was quietly set aside, buried under technical debates and scientific skepticism. But was it truly inconclusive? Or was something deliberately ignored? Why didn't NASA continue the search? Since Viking, NASA has sent a fleet of advanced rovers and orbiters to Mars: Spirit, Opportunity, Curiosity, Perseverance. These machines have transformed our understanding of the Red Planet, revealing that it once had rivers, lakes, and even vast oceans. They have found organic molecules, detected methane in the atmosphere, and uncovered chemical evidence of past habitability. Yet, not a single mission since Viking has carried an experiment specifically designed to detect life. Why? If Viking's results were truly inconclusive, wouldn't the logical next step be to send a more advanced version of the same experiment? Yet NASA has consistently avoided doing so, opting instead to focus on understanding Mars' geology and climate. Could it be that NASA already suspects the answer? For over 4 decades, Dr. Gilbert Levin fought tirelessly for NASA to retest the Viking experiments. He wrote scientific papers, made public appeals, and challenged NASA to send another life detection mission. His efforts, however, were repeatedly ignored. Meanwhile, the evidence kept piling up. Curiosity rover detected methane, a gas that, on Earth, is primarily produced by living organisms. Perseverance found organic molecules, potential building blocks of life. China's Zhurong rover uncovered evidence of a Martian shoreline, confirming that ancient oceans once covered the planet, and still, no new Viking-like experiments have been sent. Could it be that NASA fears the implications of confirming life on Mars? What if Martian life isn't just simple bacteria, but something far more complex? What if life on Mars never truly disappeared, but instead found a way to survive in the shadows? The answers may already exist, hidden in the data, buried in reports, or locked away from public view. And perhaps, just like the Viking results, the truth has been quietly set aside, waiting to be uncovered. More evidence emerges: Mars. A desolate, barren wasteland of dust and stone. At least, that is how we have come to know it. But what if this perception was merely a shadow of the planet's former self? What if, beneath the rusted sands and the silent valleys, Mars once thrived? For years, planetary scientists have uncovered whispers of a forgotten world. The dry, cracked surface of Mars tells a silent story, one of raging rivers, sprawling lakes, and oceanic tides that once kissed the shores of an alien coastline. Once, water ruled Mars, carving canyons, shaping valleys, and breathing life into its red soil, and now, thanks to China's Zhurong rover, we have found the first undeniable evidence of something truly astounding: Martian beaches. Let that sink in. Beaches. On Mars, beneath the dust, beneath the centuries of erosion, there remains a ghostly imprint of waves that once lapped against an ancient shoreline. Smooth, sandy slopes rise beneath layers of Martian dust, perfectly preserved under the weight of time. To any trained geologist, the unmistakable patterns speak for themselves. This was an ocean. A vast, living body of water stretching over the Utopia Basin, an impact crater larger than any found on Earth. But this discovery leads to an even grander question: if water once existed in such abundance, could life have followed? The evidence does not stop there. NASA's Curiosity rover, tirelessly navigating the hostile terrain, has picked up something even more perplexing: methane. Methane, the simple molecule often associated with biological activity. On Earth, nearly all methane comes from life: microbes beneath the soil, decaying organic matter, even the breath of living creatures. And yet, Mars has methane spikes. Not just random fluctuations, but recurring patterns. Its levels rise and fall with the Martian seasons. Why? If Mars was a dead world, where would this methane come from? The presence of methane suggests something hidden beneath the surface, something we cannot see, something that breathes, metabolizes, and reacts to the changing climate of Mars. Is it the final, elusive clue that we have been searching for all along, or is it merely the beginning? The most convincing discovery yet: in the year 2022, humanity took another step toward unraveling the great Martian mystery. The Perseverance rover, armed with some of the most advanced scientific instruments ever sent to another world, made a discovery that left even the most skeptical scientists speechless. Within the jagged rocks of Jezero crater, it found something astonishing: organic molecules. These weren't just random carbon compounds, the kind that could form through non-biological processes. No, these were complex molecules, the kind associated with life. On Earth, similar formations are often found in environments once teeming with microbial activity, and then, the discovery grew even stranger. As Perseverance's instruments scanned the landscape, they detected unusual white veins cutting through the Martian rock. Thin fractures filled with calcium sulfate, a mineral that forms when liquid water interacts with rock over long periods. This alone suggested that Mars' past was even wetter than we had imagined. But there was something else. Something even more mysterious. Scattered across the surface of these ancient stones were tiny, circular patches with darkened edges, features eerily similar to microbial fossils found in lakebeds on Earth. Scientists call them leopard spots. On Earth, these patterns form when bacteria influence the mineralization process, leaving behind a permanent fingerprint of their existence. Mars, a lifeless world, should not have such features, and yet, they are there, staring back at us from the rocks of an alien world, silent remnants of a possible ancient biosphere. Could this be the final, undeniable proof that life once thrived on Mars? If so, what happened to it? Did it vanish entirely, leaving behind only these chemical ghosts, or is it still there, waiting beneath the surface? The real reason Mars is red: for centuries, Mars has been known as the Red Planet, its color attributed to rusted iron, a sign of a dead, oxidized world. But what if we were wrong? What if Mars is not red because of rust, but because of water? A recent breakthrough study has challenged everything we thought we knew about the planet's past. Researchers now believe that Mars' surface is covered in ferrihydrite, a mineral that only forms in the presence of liquid water. This revelation suggests something incredible. For millions of years, Mars was not a dry wasteland. It was a planet covered in water, a world of lakes, rivers, and rainfall. The presence of ferrihydrite tells us that Mars once had a hydrological cycle, just like Earth. Clouds formed, rain fell, rivers flowed, and oceans churned. But this discovery does more than rewrite history. It forces us to reconsider the fate of Martian life. If Mars was once Earth-like, could life have arisen in its ancient waters? And if so, what happened to it? Did it disappear with the evaporation of Mars' oceans, leaving behind only chemical traces in the rocks, or did it adapt, burrowing deep beneath the surface, hiding in underground reservoirs, protected from the radiation that now bombards the planet's surface? The red planet is no longer just a barren, lifeless world. It is a planet with a past full of water, a planet where life could have thrived, and if life once thrived, then perhaps, just perhaps, it still does. The future of Mars exploration, a final revelation. The future is approaching faster than we ever imagined. The next decade will bring a new era of Mars exploration, unlike anything before. More advanced rovers, more daring missions, and, perhaps most significantly, humans. Elon Musk's SpaceX is racing toward an audacious goal, sending the first humans to Mars. Not as mere visitors, but as settlers, colonizers of an alien world. And in doing so, they may finally uncover what has long been hidden beneath the Martian dust. For decades, we have searched for answers. The evidence has been piling up, each new discovery painting a clearer picture of a once-living world. Rivers flowed, lakes stretched for miles, and oceans kissed the shores of an ancient coastline. Organic molecules, the very building blocks of life, have been discovered. Methane gas mysteriously fluctuates, and strange, microbe-like formations have been found in Martian rocks. Mars was habitable. Mars had water, but what if Mars never stopped being alive? And if the signs are everywhere, then why isn't this the biggest discovery in human history? Why does mainstream science still hesitate to say what seems so obvious? Could it be that the truth is something too shocking to reveal, or is it possible that we have already found life, and for reasons unknown? It has been hidden from us. The answers may already exist, waiting beneath the surface, buried beneath layers of dust, rock, and time. And soon, whether through robotic exploration or the boots of the first human pioneers, the truth will be revealed. What do you think? Does life exist on Mars? Is there something NASA isn't telling us? Or have we simply been looking in the wrong place all along? Let us know in the comments below. And if you want to be part of this journey into the unknown, don't forget to like, subscribe, and support us on Patreon, where we continue to explore the greatest mysteries of the universe. Stay curious.